natural evolution of the internet, and in a couple of years no one will talk about it because it will be the internet. So I'll start a conversation. If you like what I've done and you want to focus on a different part of the architectures for next time, I'll focus on sensors or artificial intelligence or whatever you want to do. But I think it's important that we have a level playing field of understanding what the infrastructure is and the implications. These slides are available. We'll talk about how to distribute them. They're available. I sent out a report to a few of you about Machinery Research's report on Nokia. I think it's a nice slide. It shows some of the key blocks. It's also revealing because Nokia can't do it. The ecosystem involved in this is too big. They don't make servers, they don't make sensors. You know, so what we see here then is our company says IoT as if they do it all, and no, they do not. So when we start looking at, well, you know, if you're going to build one of these platforms, how do you do it? Well, the big guys, you've got Amazon, IoT, and real-time streaming is Kinesis, GE Predix, more of an industrial IoT, HPE is universal IoT. This was mainly out of telcos, but they're also, you know, when I was with them, we were doing a lot on edge analytics, real-time drilling, offshore oil rigs, and so on. IBM Watson, probably the best known of the lot. Intel are moving up the stack. Microsoft Azure, very popular one, and I believe our next speaker will be talking about Azure. And open source, and to my mind, it is open source that's actually driving the innovation. When you look at all these clouds that they use, they're all built on Cloud Foundry. If you look at where the business value comes from, it comes from applications. You'll start seeing more applications in containers like Docker that are deployed in Cloud Foundry. However, all is not simple. You see also in here that you know, there are thousands of companies. Every company says there's too many standards in this industry, nobody's agreeing, there's too many platforms. So what we'll do is we'll create our own platform and our own standards, and before you know it, the complexity evolves even more. Mac Trucks, well worth watching out for. He's a blogger from Silicon Valley. Says some interesting things. So let's then start talking about the architecture. So in a most popular version of IoT, I've got my actuator. So this can close something, open something, like a valve or something. I've got my sensors, wireless or wired. They come into a gateway. Sometimes if you've got a clever sensor and you've got cellular, a SIM card in the sensor, you can skip the gateway and go straight to the cloud, and then the cloud. So the information comes into the cloud, it gets processed in some analytics engine, and it gets sent back to an actuator that changes something. So you start perceiving the way that this physical world is, making a decision and changing it. And then you've got your visualizations as well. This is the most common type of IoT architecture where everything goes to the core. However, you have some situations where you can't get to the core, or it takes too long to go to the core and come back. So we were talking to a customer when I was with HPE that was drilling in Gabon, sending the real-time drilling data from Gabon back to Houston. It was being processed in Houston, sent back to Gabon, so about a 15,000 mile round trip, and it was taking 5-10 minutes before the real-time information turned up, which is no good. The guys are already in trouble. The computer just confirms they're in trouble. So what we were doing then, we were pushing compute power out to the edge. And this is an important move because you're now pushing compute power out there, but you're also seeing analog data. There's a lot of innovation going on where we don't even need to get into digital. We can start doing analog analytics on the edge and then into digital. So first thing, IoT assumes that everything's got an IP address, and not everything does have an IP address. So that's the move forward. Edge compute is making a big difference. Next one on this is distributed mesh compute. So you'll start seeing this more and more in connected car, where the cars on the road start talking to each other. One car puts its brake on, it slows down. Dynamic routing of roads and whatever you can come in. If you look at the way that your sat-nav works today, it takes every car off at a junction to avoid a traffic jam and puts you in a traffic jam on another road. Whereas when you start getting into these more dynamic algorithms, they'll avoid all that. This also brings the possibility of distributed other things, distributed storage. Why do I need to put everything in a central database, a central data center? So this then marks a move towards a distributed architecture. Then we come to the industrial side of things, and these guys in the industrial world have been using their SCADA systems for many, many years. The culture this is what we call OT, operational technology, as opposed to IT. So the guys in the OT space, the dominant culture is, if it works, don't change it. So when you start getting in the OT space, it's not uncommon to come across everything being run off Windows 95, because that had decon that allowed device-to-device communication. So you've then to win the argument about, it's not been supported for 15 years. If you want to get into some clever stuff, you've got to move it up. But this then is the big play for a lot of companies, and this is where I think places like Sheffield, there's a business opportunity in helping companies move into this area, bringing more intelligence and so on. The other problem is that when the guys who use the SIM cards to communicate back to base, they sell a device, a valve, into this world, they bypass all the security. So we're now seeing with connected card, it was I forget what it was now, a very simple thing in the car that bypassed all the car's firewalls and everything. So they created a vulnerability. So security in IoT is massive, absolutely massive. So in this world, your enemy can shut down all your power supply. They've got a military advantage. So this will become more and more dominant. So there's all technology trade-offs. This is looking at the different ways in which you can communicate, different types of radio solutions. We got a possible speaker next time from Sigfox. Sigfox is deployed in Sheffield. There is something we could take advantage of. It will have a cost. What's the case for us to do it? That's narrowband. I've got me 15 minutes, so I mean I can go deeper if you want. So if you need to know more about why the different radio frequencies work, we can have a chat. I've put it on a PowerPoint, on an Excel sheet to look at it, but this was just comparing some of the different radio solutions that you can use to communicate between devices and so on. And what we see in the IoT, when you first look at it, it's just so complex. There's just so many different things out there. And the way that you manage complexity is you find a framework in which to organise your thoughts. How shall I think about this complexity? And there's a number of ways you can do it. One of the popular ones is to think of it as device-to-device communication. And there you'll see things like a distributed data service. If you want to take a more device-centric view, there's OPC, unified architecture and so on. Then you've got device to server, and you may have heard of them, TQQ, and then there's server to server, APQQ and so on. So there's all different technologies, and the key thing is that it's looking at a way of thinking about it. How do I unravel all this complexity? If I'm a solution architect, I've got my use case, how do I pick which ones I bring together? How do I know that the protocols that they will use will all work together? So that interoperability is not the challenge that it is. And there's my 15 minutes. Am I okay?
Yeah, you're fine. That was great.
Okay. I felt as though I had to go 100 miles an hour.
We've got time for a few questions.
Yeah.
I think. So let's thank Roy first of all. So yeah, we've got a question.
Yeah.
I'm interested to hear about your company, what you do to tackle all this.
Well, yeah. So I've left. I've got my severance. I broke free, and I've decided to start a company. And when I've worked with a lot of industrial situations, the real problem I think in this space is adoption. It's not the technology. The technology is there. Whatever problem you've got, we've already got a technological solution somewhere that will solve it. The problem is, how do you game change the way things are done? It's the people side of it that's the real kind of area that I don't think is explored or done collaboratively. So technology is done to them. We were involved in a project where we put video cameras on an oil rig, and it really was for safety. And within 30 minutes or 40 minutes, the cameras were pointing out to sea because the guys thought Big Brother and knocked it out. I was speaking to some guys in the shale plays in Texas, and this guy said to me, he said, UIT guys, whenever this starts off with UIT guys, you know you're in trouble. You know that the next bit's going to be provocative. He says, UIT guys, you take 10 days to understand the problem and come up with a solution. You take 100 days to design a solution, build it and deploy it. And then 1,000 days later, somebody does something different. And that really did stick with me, because that to me is the real challenge in all of this. Instead of the IT industry doing things to people, if only we can do it with them, then there's less change resistance. So that's where my company comes in about IoT transforms. It's 3 weeks old and I've yet to have my first customer, so but that's the intent.
What kind of customers are you looking for?
The ones with money. No, anything. I mean, I'm very interested in self-organising teams. I see the future, when you look at a lot of hierarchical companies, they're too slow because the hierarchy gets in the way. I think you're now in an era where technology can actually change the way we organise, the way we build our organisations. So I'm very impressed by some nurses in Holland called Buurtzorg that self-organise, and you know, from 8 nurses in 5 years they own 80% of the Dutch home care market, and you know they've got no overheads, and it's all patient focused and so on. So I think IoT can play a really powerful role in changing lots of things and making it more effective and focused on the purpose rather than the usual stuff. Does that happen?
I've got one. So around the slide you were showing with Nokia, you were showing there's lots of layers effectively which no one company can service. Is the technology there for those layers to speak to each other, or is that a lot of work? Is that
no, they're all there. So you go on the next slide. These guys have all got an ability. If you go with Microsoft Azure IoT, they've got all the layers. Perhaps not got the edge compute that they've got in HPE, but they've got all the parts. I mean, most of these technologies rely on a lot of open source. That's where the real innovation engine is. But no, they can all give you something, yeah. It's not.
So somewhere like Sheffield was looking to implement a framework for that, would they have to stick to a single provider, or could they work across multiple providers quite easily? Well,
a better way to think of it is, would they put it all in one cloud? Because really what these are extensions to their cloud strategy. So if you started off with IBM, you're in an IBM cloud, you know, Blue Mix and so on. If you look at one of the others, and that's where it gets messy. If you wanted to be really clever, what the council should do is say, hang on a minute, it's all Cloud Foundry. Why don't we create our own Cloud Foundry instance built for the councils, by the councils, and share it amongst different cities and so on? But they won't do that, will they? Politics gets in the way. Does that answer your question?
Yeah.
I think you've hit the nail on the head. The technology is not the issue here. The technology changes, it'll evolve, it'll adapt. But what I try and do as part of my day job is to sort of preach it's the outcome benefits based that we need to be looking at here. We can reverse engineer things to fit the technology.
Yeah.
So forget about the technology. This is not what it's about. It's about what are the outcomes, how can we deliver energy savings, operational efficiencies, or something that's going to be tangible benefit.
So my background is mainly private sector. I'm just straying into the smart cities, which seems to be dominated by public sector. And the first thing that strikes me is there's nobody jumping up and down about a specific problem.
It's governance.
You know, what is the real benefit of a smart city, or our benefit of a smart city, that says everybody in this room, you know, tomorrow morning let's get together and build X, Y, Z. You know, that clarity is not there that it is in the private sector. Or at least I'm not seeing it. It might just be my ignorance. It probably is there. I'm just too thick to see it.
Maybe it would be if councils had time and space to imagine rather than.
Yeah. But I think that creative aspect, there's very little you can't do now. I mean, why do we need street signs? You know, look at all these connected cars that are coming out. You know, refuse. How many times do the traffic lights go from red? You go 20 yards and it's red again. You go 20 yards and it's red again, because they're all on times rather than the actual flow of traffic. You know, there's so much more intelligence can be brought to the city through this digitisation.
Great, thanks Roy.
Thank you.
Excellent.